Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics.
Welcome to Speaking of Reliability. This is Carl Carlson.
And this is Dianna. Hi, Carl.
Hi, Dianna. I've wanted to chat with you a little bit about a subject that I'm always learning about. There's no course you take in the subject that I'll bring up, but it's almost like a puzzle. What is it that is not in a course but is everywhere? I've learned about it early in my career, but I'm building on it. And it's the subject of interfaces and how interfaces get involved or dealt with in reliability and the other tools, like the tools of reliability. And I just love to talk back and forth and see what some of our experiences are on dealing with interfaces.
Yeah, interfaces and reliability is probably more closely related to the interfaces of things in a product, right? One system communicating to another system, or some sort of feedback loop happening, or just one part being next to another part and having to work.
Yeah, there's different types of interfaces. There's a physical interface where you have mating parts, and you might have some bolts holding them together, or adhesive, or just pressure. There's energy transfer would be an interface. So you have a spring that's working back and forth in some way. So there's transfer of energy. There can be fluid transfer, which would be a type of interface where you're going from one area to another. And of course, there's data interfaces, which would then show up on a software FMEA or in some integrated type of FMEA.
Yeah, and I want to add user interfaces too.
Yeah. Very good. Very good. User interface, human interface. Yeah.
Yes.
And I'll just share a story. I've shared this a few times, and it's probably been in podcasts over the years, but back in General Motors, back in the 90s, GM would purchase each of the different vehicle types once a year. And I'm talking Toyota Camry or, BMW, different model. So different models, all of them. So there'd be like a lot of vehicles, and they go out to the proving grounds, and people would run them around the tracks to be equivalent of 100,000 miles. So 100,000 miles are equivalent. And when there were problems of these vehicles, we'd tear them down and to get the root cause, the cause of it.
I never knew about any of this.
Amazing program, including all the GM vehicles, because you don't get to root cause reliability problems very often. And because in the warranty system, the warranty, even on parts return, you don't get a lot of information.
Yeah, right.
Often set up for accounting, paybacks, and things like that. And so this is a terrific opportunity. And what they did is they had a large room. It's almost like an airplane hangar, very big room with tables. So you'd have the Toyota Camry or the different vehicles. And then at the end of the 100,000 miles or equivalent, and that includes Belgian blocks where you're doing different types of stresses. At the end of that, they'd tear down the vehicles and they'd lay them out on the airplane hangar type tables.
Okay.
All next to each other, so you can see what the wear and tear on. If you're interested in solenoids, or you're interested in valves, or you're interested in whatever, you can just see how the different parts hold up. And then they had this database where all the problems were in there. And long story short is I had an intern one year with a lot of interns. And I said, here's an interesting project. Let's find out how many of the problems that are in the database are at the interfaces between two components or interfaces between two subsystems or interfaces in some way, and how many are the actual component failing.
Yeah. Okay.
And it's not, I mean, it's not totally black and white, as just because there can be some fuzzy areas there,
Sure.
but we got some idea of it. And from that study, it was around 55% of the problems were at interfaces,
Wow.
which is way more than I thought.
Yeah.
And since then, after GM, I did about a little over 20 years of consulting with companies and teaching. And I'll always bring that up. Tell me about your interfaces, what kind of problems you see. And 60, 70%, 50%, it was always 50% or more of the problems. So I've had that confirmed over and over, that 50% or more of the problems occur at interfaces. And that has opened my mind to how important it is to deal with. Like I asked a question, if you're doing a system reliability model, so you have a widget system, but you have this component A, component B, component C. And some people do the block diagrams,
Mm-hmm.
block A, block B, block C, and they'll connect them. I go, what about the interfaces? How do you model the problems that occur at the interfaces? Well, it's not normally in there. And another example is on FMEAs, where we'll do a nice FMEA block diagram. We'll show lines between them, but we don't analyze the interfaces. So in my practice, not only do I do an FMEA block diagram showing the interfaces, I'll number those interfaces and bring them into every FMEA as functions. So you have component A, component B, interface AB.
Oh,
And then
okay.
the function list will be function of AB is this. So if it's maybe an adhesive between two parts and the interface is the adhesive, what's the function of holding those parts together? And it has to be described in some way. Then you can FMEA that function. And by doing that, or it could be fasteners, or it could be, just ways that parts interface with each other. And then what's the function of that interface? And it might even be to make sure parts don't hit. Like you got to be sure things don't hit each other or interact physically.
Yeah.
Maybe you want them interacting and you want them to stay a press fit. Whatever that function is can be FMEA'd. So I deal with it that way. And
So how many aha moments do you get from teams when they do add the interactions to the FMEA?
let me say I get more aha moments on interfaces than I do on anything else, because they're often forgotten.
Yeah.
I've seen FMEAs, a lot of FMEAs that will go through the entire FMEA process and miss the interfaces. And that's a huge mistake because 50% of the problems are at the interfaces. So those aha moments when they start picking up the interfaces, and I have interfaces as one of the quality objectives in my FMEA teaching and that I've introduced into FMEA standards, is whether interfaces are visually shown in the FMEA block diagram and brought into the FMEA. That's a quality objective of the FMEA, one of 10.
Now, I've seen teams when they're developing design concepts, they'll come up with a systems diagram, and it could be a block, sort of like the reliability block, but you're not, calculating reliability. It's just representative of a design. So you would have a motor, and you would have like the electrical plug, and you would have the case, that kind of stuff. And then I've seen them develop that into a rough geometric layout. So what's laying next to what?
Yeah.
What's near another thing. But then they take those two things and they draw an interactions diagram. So you have this part and this part, and there's an interaction between them because they're right next to each other on the geometric layout. So like you were saying, you have this motor next to this circuit board, and an interface there, is it a gap that needs to be maintained? But if it's not maintained, what energy is transferring? So you add the energy transfer between those two blocks in an interaction diagraph. So is it heat? Is it vibration? That sort of thing. And that's used to kind of help identify what reliability problems there could be with interactions.
That's a great technique, Diana. That's a great technique. And I try to bring, I agree with that completely. And I think if we integrate that into the FMEA block diagram, where you show the different interactions and if it's energy or energy transfer, or if it's a physical connection of some kind, and then label it as to what you can use, an acronym or something that helps to define the function.
Yeah.
You're trying to define in the FMEA. And then you can take that function, let's say it's a spring that is transferring energy from one component to another, or keeping a certain amount of force or distance even. And then you bring that into the FMEA and you describe that function. And then if you do a good job of FMEAing, you won't have a failure at that interface. And that's a technique that a lot of people don't use. They'll just go about the FMEA the old-fashioned way, which is what are the components in the system? And that'll be their FMEA block diagram. And then they'll do the FMEA and they'll miss out on the interactions. So, but I like the way you're describing it, because that would be a terrific input to an FMEA.
So the interactions that you're talking about, they're added to a system FMEA or a design FMEA?
It's a good question. In our latest standard, and we're developing it as we speak, we're right to the tail end of it. It replaces 1629, the mill standard on FMEA, and it'll probably replace a lot of other standards on FMEA. And interfaces are in there, and I've just lost my train of thought. Ask me the question again. I'm going to get it back.
If the interactions, if they're added to a system FMEA or a design FMEA.
Thank you. I just lost that thought. We look at the system FMEA as a design FMEA on the system. And so we really call it a design FMEA at system level. I just wanted to mention that because people, when they'll see the new standard, they go, what happened to system FMEA? Well, it's part of design. But on a system FMEA, one of the primary objectives is to get the interfaces between the subsystems. So if you have a system like a tank, and then you might have a turret assembly, and that turret assembly is going to interact with some other part. Maybe it's the frame of the tank. And okay, what's the interface? Well, it's how we hold the turret where it is and allow it to move and what have you. Or a vehicle, you could have a seat system, and then you could have, again, the frame or the body, because it's integral to it. And then what's the interface there? It might be some bolts that are holding the seat onto the frame or the body. And then you have, sometimes you don't want certain interfaces like EMI. So you have the electronics that are involved in maybe the entertainment system. So the point of the system FMEA is not just what does the system do and what can it do wrong. It's the primary interfaces between the different subsystems. And then when I do a subsystem FMEA, I'm looking at the interfaces between the components. So I'll say, what is the and subsystem to other subsystems? So you could have that in there if you haven't done it in the system FMEA. And on the system FMEA, I'll look at interfaces to user that you brought up, which is really important, or the interface to adjacent systems. So I like to get the interfaces in the system FMEA or the subsystem FMEA. If I'm doing just a component, then I'm typically not focusing on a lot of interfaces.
Yeah. Okay. So the system FMEA, the top level, looking at interactions with the user. Sometimes I've done a use FMEA for that. But then you're at the top level system, you're looking at the interfaces between the subsystems. But at the subsystem FMEA level, you're looking at the interactions between components. So
Yeah, that's
right?
the way I do it. And the reason is I don't want a big, massive FMEA. And there's
No.
I don't know are you familiar with the AIAG VDA?
Yeah.
That's an example of a massive FMEA. And I've written a lot about it. And in fact, I even debated at Oakland University with another group. We had two of us that had concerns about the AIG VDA.
I mean, you need a software solution to handle that, right?
What's that?
You need some sort of software solution to be able to handle that.
Yeah, and you do, and they do.
Yeah.
But it still gets a massive FMEA, which to me is not what you want. You want to be selective on where you focus. You want to stay at the highest risk areas and not try to include all failures on everything, including very low risk, because people don't have the time, the money to do FMEAs on everything. And so that's one of my early lessons, is to be selective. I would rather do fewer FMEAs, get them done on the highest risk areas and do them really well, than a massive FMEA on everything that's just to fill out the database or fill out the forms and doesn't have a lot of value.
Yeah, right.
So, and that's where I'll do like a subsystem FMEA. But that doesn't mean I'm going to go inside every component. I'm going to go inside the components that are higher risk.
Right.
And I'll actually do a DFMEA on those components rather than, so I'm very selective on it and try to stay focused on risk and make sure we don't have any safety or higher risk performance issues within the scope of the FMEA.
Yeah. And in fact, when doing FMEA, maybe this is part of the trap that we fall into and why we miss interfaces, is we kind of tend to go for the low-hanging fruit first. And we try to populate or think about or control all the failures that we already know about because we know about them. And we don't, I don't know, I guess we have to be intentional about challenging ourselves with those areas of risk. So recognizing that there's those potential areas of risk that we really don't know about. And those are really the areas that we should focus on to better understand the risk so we can make decisions.
I agree completely. Let me clarify something, because people would say, well, okay, yeah, but you can't just stay focused on high risk because you might miss something that turns out to be high risk. Let me clarify that. In an FMEA, and I'll do this on reliability teams as well, but in the FMEA, if I have the right people in the room, and that's critical, right? Experts in the room, and no one is concerned about an issue, I'm not going to take it up. But if one person is concerned, I'm going to take it up, because we don't want to, majority, people have blind spots, and you don't want to, you want to take up, like very often a single person in an FMEA team turns out to have the right answer. And so you don't want to talk people down and say, well, what do you think? And then do a vote on it. If I want to get to consensus, and if they brought up an issue, I want to take it up and then challenge them if need be if other people disagree, continue talking about it until we get to a consensus on it. If it's not a concern, we won't pursue it. If it is, we will. But I use that level of concern. If no one is concerned about it, the meteor coming through the window and striking your microphone, then I'm not going to put that in the FMEA.
Unless you're on the space station.
Unless you're not, exactly. If you're on the space station, well, you don't want it coming through the space station.
Environment matters.
Yes. Environment matters, exactly. So, but since interfaces are such a big percentage of problems, I want to be sure we've got the most important ones. Same with a block diagram. I was with a welding company, and we started with we're doing an FMEA on new welding equipment. This is state-of-the-art welding equipment, not just the simple. This is equipment that'll do all kinds of different types of welding, and so it's complex equipment. I said, let's start with a block diagram, and it was complex. I had it on a big wall, and we worked at it and got all the lines right, and people are realizing things as we're talking. I kind of forgot about that connection. So just getting it visible was really useful. Then let's say, I forget what it was, but let's say there's 30, 40 interfaces. I don't have to bring them all in. What are the most important interfaces? They might say, okay, that interface, the same one we've had for the last 10 years. We've never had a problem in it.
Yeah,
you know
that. So just, yeah.
Let's not waste a bunch of time.
Right.
Because people tune out. You waste time, they tune out, and they're going to miss the important things. And so I'll narrow down. I won't bring in all the interfaces. Same way I won't bring in all the functions. I might do a function list, and one of the functions of the microphone that I have here, obviously we want to bring in the clarity of sound and the basic primary functions. But there's also a shell on it, and that shell has got a coating on it, and maybe it shouldn't scratch. We may choose to not bring in that function of the shell coating. It might, on the other hand, if it's for a TV station and the microphone's in front of everybody, and everybody's seeing it, maybe that scratching or corroding of the shell matters. So point is, I'm not going to bring in every function. I'm not going to bring in every interface necessarily.
So it's really, FMEA is a process, and I always view the table as the result of a team process. So in the process, you mentioned a couple of things. You want to maintain focus on the important things so people don't phase out. So, make the FMEA process matter. Now I lost my train of thought, Carl. You have to pick me up.
Well, we talked about maintain attention on the important things, bringing it back to interfaces, maintain attention on the important interfaces, maintain attention on the important functions.
Oh, yeah. The thing I wanted to say is sometimes people feel the need or the itch to just be thorough about it. So a way to kind of alleviate that itch for yourself and your team is to just put a sentence or two, or however much you want, in your risk management plan describing this is how we're going to approach our FMEA. This is how we're going to prioritize things. These are the things we're going to focus on. And you can sort of get agreement with the team on that too, so to kind of stay away from that need to be so thorough and capture everything. When you, like Carl said, you really want to catch the important things and the interfaces. Yeah,
the important concerned areas. The severity also is a big help, because if something is high severity, I'm going to dig a lot deeper in terms of causes and that type of thing. And in recommended actions, I'm going to be very thorough with multiple recommendations, unless we get the occurrence and detection down at 1. And so there's ways to parse this so you don't miss important things. If the severity is low, and I'm not going to work getting that occurrence to 1 and detection to 1. So there's, throughout the whole FMEA, it's a principle of understanding what risk is and staying focused on risk. But now let me bring it back to the listeners. What's been your experience as a listener with interfaces? Do you include interfaces in your reliability diagrams, in your FMEAs? If so, how? And what questions do you have for us? Because a lot of what we do here is based on questions from listeners. So I just wanted to ask people that are out there listening to this podcast, if you really ask you if you could get in touch with us about what your experience has been on interfaces and anything else, and what kind of questions you have for us about interfaces or about anything.
Yeah, we'd love to hear from you. Visit ascendo-reliability/go/SOR. You can also leave a comment on this particular episode. But yeah, reach out and share what you're doing.
Okay, fantastic. I enjoyed chatting with you on this one.
Yeah, me too, Carl.
Okay, see you later.
Until next time.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.